No to słuchajcie, ja chcę dobra, dlaczego po polsku? Po angielsku planowałem prowadzić prezentację. We'll switch to English. All right. I would like to start with the question, maybe a few questions, just 3 questions. The first question will be, who already knows or work with the structured concurrency before? Could you raise your hand, please, if you work or you know what structured concurrency is? Anybody? That's super cool, actually, because this presentation will be maybe more interesting for you because it's a new topic, and I think new topics excite us. I also would like to ask 2 more questions, related topics, like scope values. Who knows what scope values are? Have you worked with those? I think that's also cool that you know what it is, because it's something also related with structured concurrency, and we will talk about that. We will talk how it's actually related with structured concurrency. And the last topic will be virtual threads. Who knows what virtual threads are? Have you heard about? Well, that's very cool. That's really cool that you know more about virtual threads, because those two, they connected with structured concurrency. All right, and first of all, I would like to encourage you to write down questions. If you will have them, just write them down somewhere. Remember, those who here on site or online, if you're still there, just write them down somewhere, and we will have time for questions. For instance, maybe you will ask, okay, could you repeat everything you just said right now? Anything, any questions you might have, just bear in mind, we will have time for that. So, structured concurrency, what it is, why it was introduced in Java, what problem it solves. Usually, I like to start with the question, okay, we have solution, but what's the problem there? What problem do we have? You know, before we will jump into solution, we need to know what problem we have in the existing world. And the problem is that we have currently in Java with ExecutorService. And I would like to look at just few examples that we have with ExecutorService. So we have the following example. Let's just create, ExecutorService. Let's just say we'll have 5 threads there, with ExecutorService. Okay, let's start some tasks. It's not so important what tasks are. Those are just test example. But we would like to have like here name, and we would like to have a surname. Let's say we start 2 asynchronous tasks, and we would like to get and receive this information. So the problem we might have here, that actually at this line, as you see here, this name get might throw an exception. What's happening if exception will be thrown? The first problem we have, that the second task, as you can see here, the surname, it will be working. It's continue working. Needlessly, we don't need that data anymore. For instance, we are interested in what person has name, what surname, and now we cannot have his name. It doesn't matter anymore. But with this situation, it will continue its work. So thus, we have a thread leak in this situation. Similar code, but let's just say something else will happen. Let's just say that we will start our subtask. We'll ask server, okay, get us name and fetch us surname. And this main thread that started all those subtasks will be interrupted. Mainly this thread that started this get user full name. Let's say it is interrupted. This work doesn't matter for us anymore. But you know what's really happening? That those subtasks, they continue, they work. They're still looking for name, they're still looking for surname, however, it doesn't matter anymore. That's the second problem we have with ExecutorService. But I want to present also the third problem we have with ExecutorService. That's actually what I said, the task continue its own work. But the third problem we might have here, let's say that we have a situation where we cannot get a surname. Just we have some failure, we have some exception, but the first task that in the previous line, just trying to get the name, it's still trying to get this name. However, it doesn't matter anymore. Because we cannot get the second surname, it doesn't matter anymore. But it still tries to do some work. So that's the problem we have with existing ExecutorService. Those subtasks quite often aren't connecting. Something happening in one subtask, it does not affect the other task. Or something happening in the main thread, it does not affect subtasks. And that's the problem we have with executor services. And now, what do we do with that? You know, we have thread leaks. How do we deal with that? Do we have any solutions? Do we need to use newest Java or something and only then it will work? Not necessary. For instance, we can implement something like, you know, try, catch. Whenever we will have exception, what actually we will try to do, we will just try to cancel the tasks that didn't work for us. And that's something we might try to do. But that might be tricky. Always remember that, okay, now I have ExecutorService. I start one subtask, another subtask. And I need to bear in mind always, okay, maybe there will be a situation when I won't be able to get the information, so I need to cancel subtasks. You know, that might be tricky always to have that in mind. So that's where structured concurrency comes. That's something what was introduced by Java to improve the situation, to address those issues. And I would like to read simple definition, what structured concurrency is. As soon as I will read this definition, you will grasp the idea right away, what structured concurrency means. So, what structured concurrency? It's a mechanism that combines parallel options of threads, treating them with vertical alignment towards modified options with access to different tasks applied via structure management. It's a joke, actually. I made up this definition, to be honest, and trying to simplify what structured concurrency is. You can think about it as a mechanism, still a mechanism, that treats multiple tasks that work on different threads. And now they are treated as a single unit of work. So whatever happening in one subtask, it affects the whole group. Whatever is happening, we work on a group now. If we cancel the whole group. Now we have group. Now we combine those tasks and work with them together. That's what structured concurrency is. I don't know which definition you prefer, more this one or one I read before, but that's what structured concurrency is. So let's just look at the example, because it's all about examples. Let's just not, talk some theory, but the most important thing is, okay, how can we use that in practice, right? That's the most important question. So the first question that structured concurrency has, it's called shutdown on failure. The first implementation that you can have out of the box, it's shutdown on failure. And as the name suggests, how does it work? Whenever we have situation like with this, we need name, we need surname, we need passel, and we need, every information, every piece of information. So that's the moment where when we use this shutdown on failure, because we need all the data. We are not satisfied with partial data. We need all the data. So that's where we will use shutdown on failure implementation. So how do we create that? We create that like this, in this way: structured concurrent, structured task scope dot shutdown on failure. And here we have implementation. So now we can start our subtasks. Like here, we have this value. We just start subtask via fork method. So we start one subtask. Another fork method. We are trying to fetch another data. After that, very important step is to use join method. We use this join method to wait for all the tasks to finish its execution. Because if we won't use join method, what actually will happen? Structured task scope will wait for subtasks to finish and simply will fail. That's not the result we want to get. So that method call is actually mandatory join. After that, what we do after that? We call method that is called throw if failed. That actually will do nothing if everything good, if everything successful. But if something went wrong and we want to have all the data, we need surname, name, passel, we need everything, it will actually throw exception. And after that, we simply can retrieve information like using here get method. Let me just get a sip of water. That's the first implementation. Shut down on failure. So whenever you need all the data, you are not satisfied with partial data, you use this implementation. Apart from that, what else do we have? We actually have implementation like shut down on success. The similar idea. We really don't care, for instance, in what shop we have the product. Either it's shop A, shop B, shop C. You know, we just want to know whether we have this product at all. Let's imagine that situation. That's the moment when you will use implementation shutdown on success. Because whenever product available to you, that's fine for us. Just stop everything else. We don't need to have any more, you know, search for the information. We have what we were looking for. And implementation is very similar. You know, you have the same fork method to start subtasks. We use the same mandatory join method to wait for all the subtasks to finish its job. And at the very end, we simply have implementation like result. And what this result does here, actually, it returns the very first successful result. Because the others subtask just doesn't matter for us. So that's what the result does implementation here. So two flavors, two implementation that we have now. We have shutdown on failure whenever we need all the information. And we have shutdown on success whenever we need just one piece of information. Doesn't matter the source, you know, whether it's A or B or C, it doesn't matter. So that's where we use shutdown on success. All right, but you know, when you will try to run use structured concurrency in practice, those examples, you might get some failure, some exception. So if that will happen, well, what do we do in that situation? The first thing, well, maybe try to use requirements, whether your computer meet, you know, basic requirements. For instance, for Intel NJ, maybe your computer is just, I know, bit old. Maybe you just need to restart your computer. I don't know how it works, but usually restart just helps with many problems you have at work. Maybe that's the second reason, or maybe the third reason why structured concurrency doesn't work for you. We simply need to add flag, enable preview as we run application. Here we have run configuration. We add enable preview flag here. And also, quite often I add this enable preview flag as a compilation option. And so now, as you add this enable preview flag, it will work for you. All those examples will work for you. But few more useful methods that structured concurrency has. We have shutdown method. Let's say at some point you start subtask and you decided, okay, now I want to stop everything. So that's where you use shutdown method. Or for instance, you have 5 minutes to wait till the information. You just use method like join until and specify deadline. How much time you have, you know, to use. That's another useful method. Or, for example, as we were talking about shutdown on success, that whenever we get any successful information, just shut down. We don't need any more information. So you can actually specify, you know, what exception should be thrown if we cannot get any information. It just will be custom exception that will be thrown if information not available. So that's how you can configure actually your structured task scope. But let's say it doesn't fit for you. Structured task scope in those two flavors doesn't work for you. I mean, you have in mind something else. Let's say you want to get every successful result and ignore, you know, all the results that didn't work. Let's say you have in mind that implementation. Let's say, no, maybe somebody told you to implement it that way, or you have idea that it will work better for that. So how do we do that? Very easy. We just extend structured task scope. And what you actually do, you need to override handle complete. Because that's the method that the result comes and you can actually check what's the status of subtask. Is it successful or it not successful? Is it if it's successful, like in this case, then just collect information. And here I also added another useful method like result that will actually return, combine successful pieces of information. And here, as you can see, also method ensure owner and joint use. And if you will look into structured concurrency, documentation and implementation, you will see that actually ensure owner and joint is quite often used to make sure that's exactly thread that started all this subtask. Exactly this thread is trying to do something, to shut down scope, to get results. No one else, no other threads. And joint, as we said, the joint, do you remember method joint? This was mandatory to wait for all the result to finish. Either normally or to throw exception. So here, ensure owner and joint is actually what it does. It's actually make sure that this method join was called before. Because if it wasn't called, exception will be thrown. I asked about scoped values. Like, have you worked with scope values? Do you know what it is? Because scope values are connected with structured concurrency. And I want to give you example of scoped values and a bit of explanation what scope values are. However, it's not like our topic. We're talking about structured concurrency. Scope values is something, it's another topic. It's another 30-minute, another presentation. But let me give you just short introduction so we will know what we are talking about. Instead of telling you, we just have scope values that work perfectly with structured concurrency. Instead of telling that, and you like, what the heck is scope values? We'll just look how we can use those scope values. Okay, scope values. So what it is? Well, scope values. Well, you can think as alternative to thread locals. Like you have piece of information you want to save and be available exactly for that thread. That's what scope values are about. But as I said, alternative to thread local, because thread local implementation has its own problems. So what scope values trying to solve those problems, to address those problems. And how do you create scope values? Well, it's pretty easy. You just call like scope values dot new instance. So that's how we get this new instance of scope value. And whenever you need to set some value for your thread, you call like here scope value where, and now we have this binding that this perform operation should hold value true. So now we set value, calling this where method. And then we have run method, and here is some method like print full name. And during the run of this method, only during the run of this method, this value that we set, like here we set true, will be available. Once we step forward, another line, its value, its binding will be destroyed. So this value won't be available anymore. I just said that it's alternative to thread locals. So what the problem was with thread locals? Why we needed scope values? The problem we have with thread locals, first of all, those are mutable. So whenever you set value, something else might change that value. And when somewhere after after you write your code, somewhere you want to get this value or change, you're not sure who set this value. You just not sure. The difference scope values is immutable. Once you set it's true or it's false value or whatever value you have, it will stay the same. It won't change. The first thing, it is immutable. And the second problem that addresses scope values comparing to thread locals is actually that scope is limited. Meaning you set this value, some operation done, binding destroys. With thread locals, it might be a situation that, thread somewhere stuck, doing some work or waiting for response from database, and this value that doesn't matter anymore isn't destroyed. So we have like thread leak, we have needless information. But with scope values, this value, once you will call this method, like print full name, this value that you said before will be destroyed. And the third problem that thread locals have, and it was addressed by scope values, what was the third problem? I will tell just in a minute. Just in a minute, I will tell what the third problem we addressed here. So that's how we use thread values. And then, if you will call start some subtask, important here via structured concurrency. We start subtask using structured concurrency. And implementation, I mentioned before, shutdown on failure. That's very important thing, because we are talking in the context of structured concurrency. So once you start subtask, whatever value you set before, it will be actually available for subtasks. Automatically. It will be inherited and available automatically. If you would try to do the same with thread values, it's actually with thread local. If you would try to do the same with thread local, as we said, that value per thread, you start a new thread, that value aren't available anymore. Of course, you may inherit those values, meaning you have parent, you have child. You inherit those thread local values and you have them. But the problem, once you inherit them, the problem you have, you need additional copying, additional memory allocation. You know, whenever you use structured concurrency, you have information, parent has information, and want to share it with child, there is no additional memory allocation. There's the difference between thread locals and scope values. The third problem that was addressed by scope values. And it's actually this automatic inheritance worked exactly when you start tasks with structured concurrency. That's why it's structured concurrency works really great with scoped values. But another also important thing to mention, virtual threads. And many of you said you already know virtual threads. And that's really great, because virtual threads, they also connected with structured concurrency. Something was introduced in Java 21. I think the biggest feature of Java 21, now we're talking what's the biggest feature will be in Java 23. So virtual threads, what are virtual threads? Is it short, just few words to tell, for those to remind us what virtual threads are. Just few slides. The biggest difference is that platform thread or normal thread, you can say, uses operation system thread all the time. And when it comes to virtual threads, they use operation system thread only when it performs some calculation. That's the biggest difference. Just give you a few more things to understand what's the difference when it comes to virtual threads and platform threads. When it comes to thread startup time, approximately normal or platform thread, it's 1 millisecond. When it comes to virtual threads, that's were introduced in Java 21, it's 1 microsecond. 1 millisecond, 1 microsecond. 1 microsecond is 1 millionth of a second. And also, when it comes to memory consumption, platform thread approximately will use like 2 megabytes, of stack. And when it comes to virtual thread, when it created, it will be like 10 kilobyte. It's much less memory consumption when it comes to virtual threads. And when it comes to number of threads, in some sense, when it comes to platform threads, like normal threads, we have a limited number of those threads. But when it comes to virtual threads, in a sense, I want to say unlimited value, but you will have plenty of them. In practice, you will create as many of them as you want. You won't even care. That's how virtual threads work. Why I mentioned those virtual threads and how those are connected with topic of structured concurrency. Well, actually, if you will look at those implementation, shutdown on success, shutdown on failure, structured task scope, all of them use virtual thread factory. Meaning, whenever you start a new subtask, it will use virtual threads out of the box. out of the box by default. It doesn't mean that you cannot change that, but it will work out of the box that way. That's why I wanted to remind us what virtual threads are and how it connected with structured concurrency. And as I said, we will be having a session of Q&As, and I want to answer the first question. So why Java 23? Do we know what will be there in Java 23? Well, actually, Java 22 documentation is already available. And as we look at the topic of structured concurrency in documentation of Java 22, we can read that structured concurrency will be added to Java 22 without changes. So the reason why I believe that structured concurrency will be added as a feature to Java 23 actually two reasons. First, we have structured concurrency for quite some time, since Java 19. So it's already pretty mature. The second reason, like Java 22, it was added without any changes. So those two reasons, I personally believe that it will be added to Java 23. And now I think it's a perfect time for questions, if you have any. Online or on site, any questions, guys?
We don't have
Or
question
comments.
online. Oh, but we have a question here.
Oh, Mariusz.
Okay, first thing first, thank you for your presentation. Your body language is so positive. Okay, so my question is like you presented that you can connect group the executed threads together, wait for failure or success, and also that under the hood there is like virtual threads used. So do you know the performance impact is positive or negative? What you observed?
Well, I can say personally I made those tests starting and trying to understand the memory consumption, but should be very positive in terms when it comes to virtual threads, as those are lightweight if we compare those with platform threads. But I'm not sure whether it was your question or actually what you expected.
Maybe a little, yeah.
We'll talk. I think we'll have opportunity to
we will
talk over pizza and beer. Yeah, to discuss that.
Okay. Do you have any
Any
more questions?
Maybe on the chat. No?
When you had a shutdown success and you had join there as well, right? So if do we wait for every virtual thread to be stopped with that join, or are we just waiting for the first one to succeed and we let the one that won't be finished or we are not interested in to just hang there for a little bit later? Like we don't. Will that join wait for the others, or will it return straight away?
Yeah, and we actually let's just find this implementation, because we have shutdown on failure. So in this situation we have this join task, and when we have some shutdown on failure, meaning whenever we have a problem, we need to close every task. Well, in this case, join will wait for them to finish successfully or exception, and only throw if failed will just do something.
Okay, so we always wait for all of them to be like completed. We don't care if like. Okay.
Meaning we'll shut down, the scope. We'll tell them to stop, but we will wait eventually at join, for instance.
Thank you. Okay, do we have one more question?
Maybe online as always.
I would like to ask, does it make it easier for debugging? We coders, we normally have fun in debugging, and concurrency has always been the problem. Will this help us in a way to make debugging more easier?
Well, as we are talking about concurrency, different threads, I don't think it ever make debugging easier, especially as we talk about virtual threads. We have millions of those threads. it makes, it's not easier, makes no easier, to make debugging. It's just easier to start the thread. So I don't think it's easier when it comes to debugging. But thank you for your question.
Okay, last question.
Thanks a lot for the presentation. Just to clarify, what is the status of this feature? It's just in preview?
Structured concurrency
Yeah.
in preview. Virtual threads already available as Java 21 feature. Without any flags, you can use it. Scope values, it's still unclear because it was preview in Java 21. In Java 22, for now, there is no mention about scope values. So it's not clear what about scope values. But when it comes to structured concurrency, still preview in Java 21. It should be preview in Java 22.
Okay. And last question. So it's a little bit philosophy. So what do you think about the future of a reactive approach? Because virtual thread, and I see that the next steps might be.
I think, I will probably repeat something what was in a Spring block. As they, have this reactive project per actor, they said, we will coexist with virtual threads. So that's their approach. It's not the end of reactive programming. They will coexist. In what form? Let's see.
Okay, thank you.
Thank you. Thank you, Pavlo.
Thank you.